Section 7.5a is about a system of inequalities. Well, a system of equations is when you graph two lines in the same plane. A system of inequalities is when you graph two inequalities in the same plane. There are a couple of steps that we're going to use, and they're similar to ones we've seen in the past. We're going to graph the boundary line and figure out if that's solid or dotted. We're going to find the shading for our inequalities, and then we're going to find where those shaded regions overlap. Let's take a look at an example. Here, you have an answer already given to you based on these two inequalities. You have two lines. One of them is solid. Notice it's solid because of this symbol right there is less than or equal to. That's why this line is solid. The other line is dotted because this symbol is just less than. Notice there's two shaded regions. There's a blue shaded region and a yellow shaded region, and the green shaded region is where they overlap. So that's their answer. So these are the kind of answers you're going to have. You're going to have two inequalities, you're going to shade them both, and then you're going to find where they overlap. So let's go ahead and get right to an example. I want to graph these two equations, so we will start by replacing the inequality symbols with equal signs. Remember, that's what we do when we want to draw boundary lines. So here, the best way to do this, I think, is to isolate the y, so I'm going to do that. Negative y equals negative 1 minus x. Divide everything by negative 1. So y equals positive 1 plus x. So that's the equation that I'm going to use, that I'm going to graph. Put this one in blue. So I need ordered pairs, x and y. Put a 0 in for x, get a 1 for y. Looks like maybe a 4 for x, get a 5 for y. You could even do something like a negative 1 for x and a 0 for y if you plug those in. So here we go. Graph that. 0, 1, 4, 5, negative 1, 0. So here's our boundary line. Notice that it's dotted because the less than symbol means we're going to have a dotted boundary line. Now we have to determine shading, and we do that by trying a point. 0, 0 is the best. So I'm going to plug 0 into the original equation. 0 minus 0 is less than negative 1. So is 0 less than negative 1? That's false. 0 is not. So 0 is on the false side or the bad side, which means I'm going to shade the other side of my boundary line. When you do this, the best way is just to lightly shade with your pencil. Now, the second equation, I'm going to solve that one for y, again by subtracting x. Divide by negative 1. So y equals negative 3 plus x. This one will be my red line. So I need ordered pairs for this one. Looks like a 0 gives me a negative 3. A positive 3 will get me a 0. And a negative 1 will get me a negative 4. So we will graph that. 0, negative 3, 3, 0, and negative 1, negative 4. There's my second boundary line. Notice it's dotted because the original inequality is greater than. So now I want to figure out shading. We do that by trying a point. Try 0, 0. Into the original. 0 minus 0 is greater than 3. So is 0 greater than 3? No, it's not. So I'm going to shade, since 0, 0 is on the bad side, I'm going to shade the good side. So there you go. That's what my graph looks like. The last thing to do now is find where these two graphs cross over or overlap. In this case, they don't. So my answer here for this compound inequality is that there is no solution. There is no place on here where the two graphs overlap. Here's another system of inequalities that I will graph. We'll start by graphing the boundary lines, isolating the y by subtracting x. So 2y equals, I'm going to write it this time as negative x plus 6, because I see a potential fraction coming. So y equals negative 1 over 2x plus 3. That's my first equation. The reason I did it that way is because this fraction might make it a little difficult for me to find x and y values. So I'm going to do this one with rise over run, with slope-intercept form. So the intercept is at 3, and the rise is negative 1, so I go down 1 to the right 2, down 1 to the right 2. I also could make the negative go with the 2, so I could go up 1 to the left 2. It doesn't matter. So there's the blue line. Okay, so my boundary line is dotted because the symbol is less than, so now I have to figure out shading. I will try 0, 0 into the original. So 2 times 0 plus 0 is less than 6, which means 0 is less than 6, and that's true. So in this particular one, 0, 0 is on the good side, so I will shade on this side of the boundary. So that's what that inequality looks like. Next one, solving for the y. Negative y, I will make it negative 3x plus 4. Divide by negative 1 for everything. So y equals positive 3x minus 4. Now just to stay consistent, rather than use ordered pairs, I'll use rise over run for this. So we start on negative 4. Wait a minute, this is a mistake. I'm going to make this a red line. So here we go, negative 4. And then rise of 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And now we'll draw the boundary line. So my boundary line is dotted because it's a greater than problem. I now have to try a point, 0, 0, to see which side I get shaded. Plug it into the original. 3 times 0 minus 0 is greater than 4, which is 0 greater than 4. No way. So now 0, 0 is on the bad side, the fault side, so I will shade over here. So there's what the shading looks like. I can see the blue, I can see the red, and I can see the area where they overlap. Now when you do this on your paper, since you don't have the benefit of the color, just take this overlapping area and use your pencil and make a really dark shade in there like I'm doing here. And show me that that is the solution. Because this dark shaded area is really what I need to see. This is where those two inequalities overlap, and this is how you graph a system of inequalities.